When repairing or troubleshooting a circuit, a multimeter is your best friend. How's it going, buddy? A multimeter is like a stethoscope for electronics. It takes abstract concepts such as voltage and current and makes them real by giving us the ability to measure them. This particular model is a manual range digital multimeter. Manual range meaning that I need to set the particular range of values I want to measure, and digital as it uses a digital display to show reading. Auto range meters, like this one, allow you to set the type of measurement you want to make without the need to specify a value range. Analog meters don't use an LCD. Instead, they use an old-fashioned mechanical needle to display their values.
Like this one?
Indeed, Lady Ada. Exactly like that rather large analog multimeter. When is that from?
This one was made in the 1960s, but multimeters were first made in the 1820s. But not much has changed since then. There's still a large display up top, a mechanical dial to select modes, and 2 wire leads to connect to your circuit.
So do people even use analog meters anymore?
Absolutely. I really like analog multimeters because the moving dial makes it easier to see patterns in your circuit, easier than a digital multimeter.
The simplest way to use a multimeter is for testing continuity, whether 2 points are electrically connected to one another. This is great for checking for solder bridges or cold solder joints within a circuit. Just make sure the circuit is unpowered before testing. First, turn the dial to the continuity setting. Then, connect the black lead to the common ground terminal and the red lead to the rightmost terminal. Then, connect the leads to each point in the circuit we want to test for continuity. If the multimeter detects connectivity between those 2 points, an audible beep will occur. If not, then no beeping shall occur. No beeping.
Here's my Lady Ada tip for using continuity mode in a multimeter. Especially in a loud office, you can't hear the beep. Cradle it against your ears, and that way, when you do a continuity test, you'll hear it nice and loud.
Nice. To measure the resistance between 2 points, set the dial to the lowest resistance setting, and then connect each test lead to each test point. If the multimeter simply displays the numeral 1 and a decimal point, that means we're trying to measure a resistance beyond the range of our current setting. Keep increasing this range setting until you see multiple digits appear. The dial is set to k ohms, or thousands of ohms, so we have a resistance of 9.88 thousand ohms. It's a lot of ohms.
You may find yourself needing to measure the resistance of a very small component, like the surface mount resistor here, and these multimeter probes are way too big. In that case, we suggest smart tweezers. Smart tweezers are basically a small digital multimeter, except instead of wire probes, there's 2 pointy tips. Grab the component with the 2 tweezer tips, then you can read the value off of the LCD.
Testing voltage is similar to testing resistance, but first we need to set the meter's dial to either a DC or AC voltage range. Here we're testing a battery, so we'll use DC ranges. Since I know this battery is supposed to provide 9 volts, I'll choose the smallest range that's larger than 9, which is 20 volts. It appears this 9 volt is not quite living up to its name, with a reading of around 4.3 volts. Sorry buddy, you don't have to go home, but you can't provide current here.
Don't forget, if you want to measure voltage inside of a circuit, it has to be plugged in and powered. If I have to measure a lot of voltages in a circuit, I like to use a probe multimeter. After you connect the ground contact, you can probe any voltage you want and see the result on the LCD.
Measuring current can be a little tricky because we need to route electricity through our multimeter, and it can only handle up to a maximum of current before blowing one of its internal fuses. The terminal on the right can handle up to 200 milliamps, and the terminal on the left can handle up to 10 10 amps, but it's not good at reading very small values. If you're unsure how much current you'll be measuring, but you know it's below 10 amps, connect to the 10 amp terminal and to the highest amperage setting. Then make a break in your circuit and connect the test leads across that break. It's showing 20 milliamps. That means I can safely switch to the 200 milliamp terminal and to a lower range. Now I can see that our LED is using about 15 milliamps of current. And my internal fuses are safe and sound.
It's pretty common for people to blow the fuse on their multimeter when testing current, but luckily it's really easy to replace. Start by turning off the multimeter and removing the leads. Unscrew any screws in the back and open up the battery case. There might be some more screws you have to undo. Then turn it over and remove the body from the plastic casing. You'll be able to see the 2 replaceable fuses inside. Check which one's blown and go to your local hardware store for a replacement.
Those are the essential things that you can measure with a multimeter. But many meters also offer the ability to measure capacitance, frequency, or even temperature. Still others have evolved to be quite small and portable. Now, if you'll excuse me, I'm off to do a bit of testing.
Hello, David here with SparkFun Electronics. Today we're going to be talking about multimeters. As any good electronics nerd will tell you, you need a multimeter. Everyone's got one next to their power supply and all their other tools. So what exactly is it good for and how do you use it? This is the digital multimeter that we carry. It's got a nice display here and we find that it's a good balance between price and functionality. Let's start off with resistance. Resistance is simply the opposition of an electrical current through a medium. Let's start off by measuring resistance. Now resistance is simply an opposition to an electrical current, correct? So you might find a resistor in, say, in line with an LED to limit the amount of current going to the LED so it doesn't burn up. You'll find resistors in just about any circuit you build. They are very common. So resistance is measured in what are called ohms, and it's indicated here by the capital Greek omega. Since I don't know the value of this resistor, I'm going to switch it to the 20 mega ohm first. So now you may be wondering why they all start with a leading number of 2. The reason is actually quite simple. When you are manufacturing the display, it's easier to have a display that goes up to, let's say, 1999 instead of 9999, because if the first digit is a 1, then it actually makes the display a little bit narrower and hence less expensive to produce. Since I don't know the value of this particular resistor, I've just set the dial to 20 mega ohms. Now this is probably way too high, so it might not even register on the meter here. So since the number here is so small, it's reading 0.04, I'm actually going to change the multiplier in front of it and switch it down to 200k ohms. You'll see it's reading 47.0 exactly. So now I know that this is a 47 kilo ohm resistor. The next thing we'll measure is voltage. Now voltage is just the electrical potential of your circuit. Common values are 3.3 volts, sometimes 5 volts for an Arduino. Back at the multimeter, I'm going to switch the dial from the ohm side of thing, measuring resistance, over to voltage. Now I'm going to set it to 2 volts, which again is the maximum that the multimeter will read at that setting. And I'm going to make sure to leave this red lead in the same slot that has a V on it. Now the easiest thing we can measure voltage-wise is a typical battery. So this first battery here is a AA cell and it's alkaline, so it should measure about 1.5 volts if it's fully charged. If I attach the leads here on either end of the battery, you'll see it measures 1.508 volts. So that's a fully charged cell. The next one here is the same type, or it's a different brand, but it should measure 1.5 volts if it's full. If I attach the leads here, you'll see it's only measuring about 0.405 volts. So that one's dead. I actually stole that out of my mouse after I used it for about 6 months. This last cell here is a nickel metal hydride cell. If I attach the leads to it, you'll see it's measuring about 1.28 or about 1.3 volts. So this I fully charged about 30 days ago and then let it sit. So fully charged it would read about 1.4 volts. After sitting it loses a little bit of its potential, so it's sitting at 1.3 volts, but that's still a good battery. So in addition to measuring voltages just off a battery, we can also measure voltages in circuit. This is when it's nice that the leads of the multimeter are kind of sharp and pointy. They're designed to be kind of poked around in circuit boards and such. This here is a circuit. This is actually circuit 14 from the SparkFun Inventors Kit. It's using the shift register and it's actually doing, it's counting in binary on these 8 LEDs. So what I'm going to do is I'm going to attach the positive lead here next to this resistor in the breadboard on the power rail, and then this one the same on the minus here. Now I stuck this resistor in so it makes a better contact. As I do that, you'll notice, the multimeter just says 1. What does that mean? Well, we're out of range. I'm expecting the circuit to be about 5 volts, so if I switch the meter here to 20 volts, now we should get a better reading. So I attach the positive lead and the negative lead, 4.94 or so. So it's still not a perfect 5 volts, but there's a little bit of voltage drop as all the LEDs flash on and off. So that's about what I expect. One thing that can be really scary is, what if I plug it in backwards? This is the universal fear of computers, right? So if I switch the leads here and accidentally put the black lead on the positive rail and the red lead on the minus rail, you'll see it's still measuring 4.92, but there's a minus sign in front. It's not a big deal. A lot of times, if I'm testing for voltage, I don't even look at which lead is going where, to positive or to negative, because if you get it mixed up, it'll just have a minus sign in front, and it's not the end of the world. Perhaps the most useful setting on a multimeter is testing continuity. Now, continuity is just an electrical connection between 2 points on a circuit. So in order to test for this, I'm going to rotate the dial here down to this symbol here. Now it's got the symbol for a diode and then a little sound icon. Now you'll notice the 2 leads, if there's no connection, that is, they're separate, it's not doing anything, it just has a 1. Now if I connect the 2 leads, you'll notice it makes a noise, and it drops from 1, and then it starts measuring the resistance. I don't really care so much about the resistance, I just want to know if there's a connection there or not. So once again, if I connect the leads, it makes a noise. We chose this multimeter specifically because it has that function of the little piezoelectric element that makes the noise. It's really handy when you're testing electrical connectivity, and you can actually keep an eye on where your probes are at and not have to, be glancing back at the multimeter. Just as an example, I've got the same circuit here. Now it's unplugged. It doesn't need to be powered to measure the, connectivity. So I'm going to put the minus lead just here on the USB case, which I know is connected to ground. And I'm going to go over here to the breadboard, put the other lead on the ground rail. And you'll see it makes the noise because there is actually an electrical connection from the USB, even your host computer, all the way through the Arduino, route over through the power lines and onto the breadboard. Same thing goes for power. If I put the positive lead here on the positive rail and then over here on the voltage regulator on the output, you'll see that's making a connection as well. Now, testing continuity is really, really useful when you're debugging a circuit. One of the first things I do after I've built a circuit on a breadboard or something, and I'm kind of wary, plugging it in for the first time, is it going to erupt in blue smoke or what? It's really nice to just set it to continuity, put one in the power, one in the ground, and just make sure that there aren't any electrical shorts across power and ground. Finally, let's talk about current. Now, you generally measure current between the power source and the draw. The draw could be anything from an Arduino to, in our case, a motor. One of our engineers, Mike, lent me this just to show me this is how he does it. So he actually has a multimeter with banana plugs plugged into the leads and a JST connector on either end. So he can actually put this in line with a JST battery, like a 3.7 volt LiPo, and measure the current from the source of the entire circuit. This is a motor I took off of one of my robot projects, and I'm just curious how much current the motor draws because I want to know which motor driver to use. I'm going to switch the multimeter dial now from the continuity setting it's on currently down to amps. So I'm going to start down here at 20 milliamps. I've got this DC power supply set to 6 volts, which is the voltage rating of the motor. I'm going to plug the positive lead into the power supply and then the minus lead onto the draw, in this case the motor. You'll see as it spins, the motor is spinning and it's drawing, or the multimeter is reading 1, which again means it's out of range. So I'm going to bump it up to 200 milliamps and try again. Under no load, this motor draws about 40 milliamps, I would say. So as I slow the motor down and make it work a little bit harder, you'll see it jumps up to about 100 and something and then stops, and then it reads 1 again. Again, it's out of range. So finally, if I switch it to 10 amps and apply it, you'll notice it still reads 0. This is because we actually have to switch the port It's a different part of the circuit in the multimeter, so we actually have to switch the lead over to the 10 amp side. You'll see it's drawing 40 milliamps again. As I slow it down to finally stall, it's drawing 360 milliamps. So the stall current of this motor is about 350, 360 milliamps. So that just about covers the basic functionality of the SparkFun multimeter. Hopefully you learned something about measuring continuity, resistance, voltage, and current. Again, we like this multimeter because it's a good balance between functionality and price. We like it because it has the audible tone for measuring continuity, so you can keep your eye on your circuit and not on the multimeter. Until next time, this is David with SparkFun Electronics.